Okay, so we're here again and we're still on the topic of graphical analysis. And this series of videos started with the graph trends discussed by Sir Sherwin, and he used the fat simulation, the moving man. And he also mentioned that it is necessary for us to be informed of these trends so that when we go to problem solving, we will be guided as to what particular values can we expect given this graph trends. So from Mom Tanet, she discussed about the calculations and related computations on the DT graph, or confirming through problem solving yung mga graph trends na ipinakita ni Sir Sherwin about the DT graph. So in my case, I will be focusing on the VT graph. So here I will try to reconcile the established graph trends from what Sir Sherwin mentioned with the calculations that we're going to have. So again, I will bring up the difference of dt in the VT graph. So difference between VT and DT graph. So this is the common error of students, and we need to avoid this. Okay, we need to be very careful with the labels. The variable on the x-axis is the time, while for the y-axis, it is the position, or of course the distance. On the other hand, for VT graph, the x-axis follows similar to that of the DT graph. So we have time, but for the y-axis, we have velocity, or the speed. So this is the thing that we want to highlight, and I think we keep repeating that they have different labels on the y-axis. Although the graphs will somewhat look alike, both graphs can have a linear one rising from left to right or falling from left to right, can have a horizontal line, etc., etc. They can have the same form or appearance but different implications depending on what type of graph you're looking into or you're looking at. Okay, so again, be very careful with the labels. Although they look alike, they may be interpreted differently, provided that we are dealing with these two different graphs. So in my case, I will be focusing now on the VT graph. So we can now see here a sample of velocity time graph, although medyo maliit lang siya. Kasi I'm still planning to add some parts of the graph a little later. So we have on the y-axis, you can see there the velocity. Let's label the y-axis para lang evident siya. So this is the y-axis, and then we have here the x-axis. Now for this labels, there is a reason behind for both cases or for both graphs, time yung nasa x-axis. For the x-axis, we place here the independent variable. So this is the variable that cannot be affected, independent variable. While on the y-axis, we have the dependent variable. So regardless of the condition, time is always unaffected by what else is happening around us. That's why it is an independent variable. So siya yung palaging nasa x-axis, while the dependent variable is always on the y-axis. So this means that in the context of the VT graph, velocity varies in time. So velocity may vary in time. The time may move forward, but the velocity may increase or decrease depending on the situation. Okay, so with that, we're going to proceed now with the reconciliation, or at least affirming or confirming the trends established from the previous video on the VT graphs. And you also have this on your reading material. Okay, so copying some questions from the graph trends, these are some of the implications that you looked into using the PhET simulation on the moving man. One is, or the following are implications on the VT graph. You can pause the video if you want to recall what the implication is. So based on the simulation, when you have a horizontal line for a VT graph, this implies a constant velocity. Constant velocity. While if it's rising from left to right, this implies a constant acceleration. This implies an increase in velocity, and therefore you have a constant acceleration. And then for, oops, my writing is, if it's falling from left to right, then we expect a decrease in the value of the velocity, but still there is constant acceleration. Pwede nating sabihin na since nag-decrease yung velocity, we can say that we have a negative acceleration, or we also know this as deceleration. And from that discussion as well, it established that the slope of a VT graph is just your acceleration. We'll look into this using or assigning values already on, well, on the graph. So, talaga bang pag horizontal line siya, it means that we have a constant velocity? Talaga bang pag rising from left to right siya, nag-i-increase yung velocity niya, and therefore there is a constant acceleration, and so on and so forth. Okay, so we have again here the VT graph. So, gusto ko munang mag-focus siguro sa slope, because it will be easier for us to detect kung ano ba itong rising, falling, horizontal line na to if we already have a concept of the slope. So, we will start with the slope of a graph, of a VT graph to be more specific. So, the slope. Well, if you would recall, the slope of the graph is defined as the rise over run. So rise over run. The rise over run pertains to, when we say rise. So this is a movement related to the y-axis. Let me label this one first. So we have y, and then we have here the x. Tapos lagyan din natin ng graph mamaya. Okay, say we have this kind of graph. And also, oftentimes, there is a unit here for the, sige, lagyan lang muna natin ng meter per second, and then we have here for time second. Syempre, if naka-meter per second si velocity, dapat yung time niya is in seconds. So, going back, the slope is defined as the rise over run, wherein the rise is the change in y, or this is the movement in terms or parallel to the y-axis. So we write here change in y. While further on, this is just a movement on the x-axis or parallel to the x-axis. So this is the change in the x. Now, if we're going to expand that, the change in y is just here subtraction between the values of your y coordinates, and then you have here the x coordinates. Now, in the context of motion graphs, okay, in the context of motion graphs, we look here on this part. On the y-axis is we have the values of the velocity. This is for a velocity time graph, VT graph. For a VT graph, the quantity that is on the y-axis is the velocity. So, ibig sabihin, ito ay mapapalitan natin ng velocity 2, velocity 1. Meaning to say, we have two values of velocities. These are the two values on the y-axis, since the y-axis contains velocity. This is for a VT graph. So this will be, we have V2 minus V1. Meanwhile, the x-axis contains the time, okay, the quantity time. So we're just going to change this into T2 and T1, meaning we have 2 points in time we are considering. So this the difference of that is a time elapsed. So isang time duration. So we have T sub 2 minus T sub 1. So if we simplify this formula, velocity, the difference between two velocities and the difference between two times, so we can probably say that we have a change in velocity here and we have a change in time on the denominator. And still, this two came from this formula here of the rise over run, or the change in y over the change on x. But in physics, when you see this kind of formula, velocity divided by the time, or the rate of the change in velocity with respect to time, this pertains to what physical quantity? If you answered acceleration, then you are correct. So this is acceleration. So that's why from the graph trends, it was already mentioned that the slope, right, that the slope of a VT graph points to the acceleration. Okay? So galing yan dito ha. We started from the slope. We uh, rewrote, we've rewritten it in terms of the velocity and time, since instead of simply y and x on our graph, we now have velocity and time respectively. So that's why the slope of a VT graph is the acceleration. Since we've already established that the slope of a VT graph is or represents the quantity acceleration, it will be easier for us to answer by the questions related to this graph. So we have here the motion of a truck for 10 seconds in terms of velocity and time. So first question, we have here which segment or segments show the the truck is in constant acceleration, From the trends here, we have here on this part, constant acceleration if we have a graph rising from left to right. So all we have to do is to identify the graphs that are steadily rising from left to right for us to say that it has a constant acceleration. So we have A, lahat ng pataas. B, we also have F. So I think we have overlooked a letter in the reading material, so just kindly add segment F. So which segments shows that the truck is in constant acceleration? We have A, B, and then F. Again, for the reason that it is steadily rising from left to right. If we have a linear graph, we know that it can be written in the form y is equal to mx plus b, right? Wherein m here is the slope, and then b here is the y-intercept. This is the slope-intercept form, if I'm not mistaken, for a linear graph. A linear graph can be represented into this kind of equation. Tapos, ano yung point ko dito? Why am I presenting this one? Kasi, kapag may linear graph tayo, kung ano man yung slope niya at one point, it will be the same at all the other points in that particular linear graph. Meaning to say, if we're going to choose F, if we focus on segment F only, at any point within that segment F, the slope will be the same because it is a linear graph. For the next question, we have here which segment or segments shows that the truck is in constant deceleration. Again, kaya hindi ko binubura yung implication sa taas para mas madali natin siyang ma-identify. So, sabi dito, deceleration. Okay, so we'll look for the part or the segments in the graph on the left that are falling from left to right. So, pababa. So, we have segment T. Again, due to human error, I think we inputted a different letter on your reading material. Kindly correct it. It should be segment D. For the next question, we have which segment or segments show or shows that the truck is in constant velocity. Okay, constant velocity. We are going to look for a horizontal line in the um, graph that we have here. Horizontal line kasi constant velocity. Ayan. Horizontal line, we have C. We also have E. So for constant velocity, we have C and E. Next, we have which segment or segments show or shows that the truck is not moving. Pag not moving sa velocity time graph, dapat nasa zero siya. As in zero velocity, right? When an object is at rest or when an object is not moving, we are looking for this type of motion, zero velocity. Tingnan natin kung merong parts ng graph na segment segment yung hinahanap sa atin, segment. So, segment. We try to find if there is a segment that lies on 0 meter per second. So, ito yung, where's my pointer? Ito yung 0 meter per second. And kung ito trace natin, well, walang segment na nandoon. So, we say that there is no segment. But, we can identify a specific time. Okay, walang segment na nagpapakita na yung truck is not moving. So, all throughout the duration of the travel, the truck is always moving. But we can select some points or specific instances. So, as in super liit na value ng time na the truck can be considered at rest. Saan yung parts na yon? Ito, at the very beginning of the travel and at the very end. Points lang siya, hindi siya segments. So, kung palalawakin natin, we can still identify uh, a very, very small amount of time na naka-at-rest yung truck natin. Maybe at the very beginning, syempre, naka-park, tas bigla siyang mag-move, going to, kaya nagkaroon ng graph na yung segment A, B natin. And then, at the end, siguro nakabalik na ulit siya sa parking area or naging at rest na ulit siya after the travel. So, yan din naman yung nandito sa end na to. Nonetheless, if our concern is the segment, definitely there's none. Which segment or segments show that the truck is not moving? There's none. Okay, we can't find any segment. For the last question on this graph, we have which segment or segments show or shows that the truck is in motion, meaning that the truck is moving. So, A, we have acceleration. Is the car moving? Yes. So, we have A. B, we have acceleration since it's rising. It's a rising graph. Does that mean that the car is or the truck is moving? Yes. So we include B. C. What does it mean? A horizontal line in a velocity time graph. This means that it is traveling with a constant velocity. Therefore, we say that it is also in motion. So, pasok pa rin siya. How about D? Yes, E, and F. So, all of these segments show that the truck is in motion. A and B, positive acceleration. C, velocity is constant. Therefore, we have acceleration is 0. Next, for D, you have a negative acceleration. For E, this is velocity is constant and acceleration is 0. And then lastly, we have positive acceleration again. Okay. Positive acceleration here. Constant velocity, meaning zero acceleration. Negative acceleration, or in other words, deceleration. For segment E, you have constant velocity, meaning you have zero acceleration. And lastly, for segment F, you have a positive acceleration. Okay, now we're going to proceed with the computations relating to the graph. So, i-quantify na natin, 'di ba? Alam naman natin yung trends na. So, this time we're going to assign values. Okay, so the question are as follows. What is the acceleration at the following times? So, ano yung acceleration niya at 1 second, at 3 seconds, at 5 seconds, at 7 seconds, and at 9.5 seconds. So how do we do that? So from the graph, or from, as we already mentioned, when we solve for, or when we are given a VT graph, the slope of this graph is the acceleration. The slope of the graph is acceleration when we have a VT graph. So with this, to solve for the acceleration, all we need to do is to solve for the slope. Kasi graph yung tinitingnan natin, so we just have to be reminded of this one, change in velocity and then change in time, which is just the change in y in terms of the VT graph and then change in x, right? But as you can notice here, we only have one time. So, hindi siya time interval. When you are given this one, this is an instant. Or in other words, we are asked to solve for the instantaneous acceleration. Okay? Pag sinabing instantaneous, yung specific time lang, as in isang katiting na time within a certain interval. Ang sinasabi ko is the average acceleration versus the instantaneous acceleration. Ano yung pinagkaiba nila? Instantaneous acceleration. Average, ang time dito is an interval, or sabihin na natin relatively mahabang period of time yung tinutukoy natin. But when we say instantaneous, kaya nga instantaneous, a particular instant. So, kumbaga, instant. So, kumbaga, pag ang pinahanap sa inyo is instantaneous acceleration, or kung ano pa mang instantaneous value yan, you are just looking at a speck of time, as in sobrang liit na time within a given interval. So, pag time interval, you can have ang kadalasan makikita niya sa problem, 1 second to 2 second. So, may interval siya. Meron siyang from to. So, 1 second to 2 second. Pag instant, hinahanap, or instantaneous acceleration ang hinahanap, ang given na time ay nasa form na at t is equal to, sabihin natin 1 second. So, this is how they are different. Ang average, ang tinitingnan niya ay yung mahabang panahon for instantaneous at that particular instant. So, another example of this, para mas madali natin siyang maintindihan, ay yung sa grading system natin. 'Di ba? At the end of the semester, meron kayong average grade sa mga subjects. So, kumbaga, ito yung magpapakita ng parang overall performance mo dun sa subject within the semester, the entire semester na. Pero kapag instantaneous, sa grading system, pwedeng yung score nyo sa quiz. So, sa instant ng quiz na yun, ito yung nakuha mong score. Pero, in the long run, okay, yung average natin will be comprised of these other tests that you encounter, or other works that you encounter within that entire semester. So, yun yung pinagkaiba ng average and instantaneous natin. Okay? So, in the context of physics, pag average, ang tinitingnan natin na sa descriptor of motion, the time given is an interval. So, usually you will see 1 second to 2 seconds. While if you are solving for something that is instantaneous, you're looking at a certain instant in time. Kaya, ang nakikita natin kadalasan sa problem is you have at t is equal to spec of time lang yung makikita natin. With that, we can go back to the problem solving. Okay. Ngayon, sa isa pong linear function, kagaya ng nabanggit ko na nung nauna pa, kung ano man yung slope niya nung buong line, 'di ba? Sabi ko we can represent a linear graph in the form y is equal to mx plus b. This is the slope intercept form wherein m is the slope and then the b is the y-intercept. Given this linear equation and given a linear graph, kung ano man yung slope niya at one point, that is true as well in other points within that same line. Why am I bringing this up? Because we are going to solve for an instant in time. We're going to solve for an instantaneous acceleration here. So we need to find the line kung saan papasok yung spec of time na yun. Let's start with the first one. T is equal to 1 second. So nasaan siya? Nandito po siya. Okay. This is your T is equal to 1 second. Yung tinrace ko na yan. Yan yung nakatapat sa 1 second. Therefore, if we're going to select the segment kung saan papasok itong time na to, nasa segment A siya. Therefore, for us to find the acceleration at time is equal to 1 second, we just need to solve for the acceleration on segment A. Kasi, this is a linear graph, so therefore, this implies a constant slope anywhere in the line. In other words, since this line also implies, okay, balikan natin yung implication, this line implies that we have a constant acceleration, meaning at any point of that line, the acceleration will be the same. So at any instant of time within that interval, we'll also have a constant acceleration. We'll have the same value. So we solve. We have y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Or, in the context of this one, we have v sub 2 minus v sub 1 all over t sub 2 minus t sub 1. What are these values we are referring to? v2, you trace, ito yun, on this part, okay, v2, we have 1 meter per second, and then minus our v1, ito, you have 0 meter per second, and then divided by T2. Ano yung x na katapat nung nakatapat na y sa 1? Ito yun, on this part, this is 2. So we have 2 seconds minus, ano yung katapat ng 0? We also have 0. Right? So we simplify, you have 0.5 meter per second squared. So the acceleration at 1 second is 0.5 meter per second squared. So we'll do the same for the rest. Let's proceed with the second one. T is equal to 3 seconds. So first step is to find which segment among segments A to F will this time instant of time fall under? Saan siya papasok? Sa anong segment siya? If you answered segment B, then you are correct. So for this one, ang titingnan natin ay segment B. So for this, we write again the formula. We have V2 minus V1 divided by T2 minus T1. So within or in the segment B, we have, ano yung end ng segment B natin? Nasaan siya? We have 3. We have 3 meters per second. Saan nagsimula yung segment B natin? We have 1 meter per second. And then divided by, ano yung katapat na time ng 3 meter per second? That's 4 seconds. Minus, ano yung katapat ng sa 1? We have 2 seconds. So we simplify, you get the value of 2 meter per second squared. Do not forget the unit when you are solving. Alright? Okay, we'll be a little fast from here. For the next one, we have 5 seconds. So, for 5 seconds, nasaan siyang segment? Okay, if you answered segment C, you are correct. So, we have segment C. From the trend, okay, from the trend, this implies that we have a constant velocity. Okay, from the trend here, when we have a horizontal line, which segment C is, we have a constant velocity. And when we say that we have a constant velocity, it implies that there is no acceleration. Kasi sabi natin, pag constant ang velocity, hindi siya nagbabago, walang increase or decrease ng speed, kaya wala ring acceleration. Okay? So, let's see if lalabas siya dito sa computation natin. So, sa segment C, we also have the same formula. We have V2 minus V1. Yeah, I know, medyo nakakasawa na siya. T2 minus T1. So, we substitute the values. Ano yung value niya? For the end of segment C, we have 3 meter per second. While the beginning of segment C, we also have 3 meter per second. As for the time, we have 6 minus 4. You just trace it based on the graph. So if we subtract 3 with 3, so we get 0 divided by 2. 0 divided by a number, you get 0. So we have 0 meter per second squared, which is consistent with the trend that we have established na kapag horizontal line ang nakikita natin sa VP graph, it has a constant velocity. Ibig sabihin, walang acceleration. Kaya, bokya, we have 0 acceleration here based on our computations as well. We're down to the last 2 examples. We have for 7 seconds and then we have 9.5 seconds. So for 7 seconds, this is or we can find this speck of time in segment D, right? Segment D. You trace it, nandito yung 7, there, ups. Hindi na naman straight ang line ko, so we have there. So with that, we solve the acceleration, V2 minus V1, that's an arrow on top of A because acceleration is a vector. V2 minus V1, T2 minus T1. We substitute the end of segment D. We have negative 3 minus negative 3, tama ba ako? The end, okay, the beginning of segment D, we have 3 meter per second. Hey, where is my, yeah, 3 meter per second. As for the time, we have 8 seconds minus, we have 6 seconds. So we subtract negative 3 minus 3, we get negative 6 meter per second divided by 2 seconds, right? Tama ba ako? So acceleration here will be equivalent to negative 3 meter per second squared. This is also consistent to the fact that if we have a falling graph or a falling line from left to right, it indicates a decrease in speed. We have a constant deceleration, or also known as the negative acceleration. That's why for the value here, we have a negative value of acceleration, which is negative 3 meter per second squared. I hope you can see that we are already confirming the trends that we established earlier regarding acceleration and it being a slope of the line or slope of a VT graph. And lastly, for t is equal to 9.5 meter per second, so we expect there a positive acceleration kasi nasa ba si 9.5? Ah, yeah. 9.5 is somewhere here. Okay, so nasa segment F na siya. So segment F. So we solve again. Acceleration is equal to V2 minus V1 all over T sub 2 minus T sub 1. And substitute the value. V2, ano yung velocity kung saan nag-end? Okay, kung saan nag-end si segment F, we have 0. correct? Meter per second, meter per second minus V1. This is, okay, you have a negative 3 meter per second. Oh, be careful with the signs, alright? Then you have, what's the value of the T2? This is 11. Yes, you cannot see it in the graph, but you can guess it. We can guess it correctly kasi yung in-betweens. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, this is 11. 11 minus, what is, ano yung nakatapat sa negative 3 meter per second? You have 9 seconds. Okay? So, 3 divided by 2. Tama ba ako? 3. Negative minus 3. So, you will have a positive value here. Dito ko na lang po, hindi na nagkasya, hindi ko natansya yung sulat ko. We have 3 meters per second squared. Mali. 3 meters per second divided by 2 seconds. So, you have 1.5, right, meter per second squared, and this is a positive value, which is again consistent with the trend we've mentioned, that if we have a rising graph from left to right, then we expect a constant acceleration, a positive value of acceleration. Yan, I hope you learned something,